Hi, okay, thank you for coming to this section. I'm very happy to be here today to talk about blue carbon. So my name is Yumo. I just graduated from University of Maryland with my PhD in environmental science this semester. Blue carbon is the carbon stored in coastal and marine ecosystems. These ecosystems are very important carbon sinks, but they are usually underappreciated. The carbon storage per unit area in the blue carbon ecosystems is far greater than that in forests. And the carbon can remain in this ecosystem for millennia, as compared to decades or centuries in forests. Coastal marsh ecosystem is one of the most important blue carbon systems. This actually is a picture of coastal marshes I took here in Louisiana. So this is around Bay Jimmy in Barry-Terrier Bay, if you are familiar with Louisiana. The coastal marsh ecosystems has very high carbon sequestration rate under the tidal environments and very low organic matter decomposition rate due to their inorganic conditions in the soil. In this study, I will use the Lancet data to study the climate feedbacks of the coastal marshes in Louisiana from 1984 to 2014. I use the Lancet data because its long-term record allows me to study the ecosystem changes for over 30 years. Also, the 30-meter spatial resolution of Lancet it's a very good can better represent the heterogeneous environment of the coastal marshes. So in Louisiana, we have freshwater, intermediate, brackish, and saline marshes from landward towards the seaward. This video is an example of the marsh's annual phenology. The satellite images shows vegetation in green and soil in brown. The figure at the corner is the phenological curve that we derive from the marsh's NDVI. NDVI is a proxy of the marsh's biomass. So a greener image is associated with higher biomass and higher NDVI. We can see here the marsh greens up around spring and gets brown over the winter. So for the video, I used the example of Marsh in 1995 here. The Marsh's phenology is quantified using a nonlinear mixed model. The model describes the Marsh's phenology pretty well. For all the four curves here, I have a pseudo R-square for 0.8 or above. And from this graph, can you see which type of marshes generally have higher biomass? Like I just mentioned, higher biomass should be associated with higher NDVI. So the green curve here for freshwater, they generally have higher biomass. That's followed by intermediate, brackish, and saline marshes. And we also find all the marshes have their highest biomass around the summer from July to August. All this is inconsistent with our field observations. In the next video, I'm showing you the marsh's phenological parameter and some environmental variables of our study area from 1984 to 2014. The marsh phenological parameters here is the peak NDVI, their highest NDVI of each year, and their growth duration, that's the length of their growing season each year. And the environmental parameter I have on the monitor here is the atmospheric CO2, sea level, and air temperature. So we can clearly see from this graph that is the coastal marshes in Louisiana are experiencing climate change in terms of the increasing sea level, atmospheric CO2, and temperature. And for the marshes phenology, we find that the marshes peak NDVI do not change over the years, but their growth duration gets longer over the last 30 years. Correlation analysis shows that the prolonged growing season is positively correlated with the increasing atmospheric CO2. Because a longer growth duration may allow the marshes to take up more carbon from the atmosphere, so actually this is a negative feedback to climate change. This video is showing the area change of the marshes over the last 30 years. Again, we have 4 marsh types. And the satellite images are again showing vegetation in green and soil in brown. The land loss since 1988 is highlighted in red. The figure at the corner is showing the marsh area in square kilometer. So overall, the marsh area substantially decreased over the last 30 years. And from the graph, on the top, then we can see where are the most of those land loss happens. That's the blue line for the brackish and saline marshes. And the loss in the brackish and saline marshes are correlated with many environmental and anthropogenic factors in Louisiana, including sea level rise. Because the reduce in marsh area will reduce their ability to take up carbon from the atmosphere, and also might release those carbon in ecosystem back to the atmosphere. So this is actually positive feedback to the changing climate. So to sum, this study found that the marshes in Louisiana are providing feedback to the changing climate. The prolonged growing season of the marshes might increase their CO2 uptake from the atmosphere, so this is a negative feedback to the changing climate. And the marsh area loss will reduce the marsh's ability to uptake carbon, and also might also cause those carbon that already stored in the system be released back to the atmosphere. This is positive feedback to the climate change. Indeed, there are many other processes in the ecosystem we need to study to further understand this. For instance, respiration and decomposition. These two processes will determine how much of the carbon that's uptaken by the marsh plants will end up as long-term carbon stocks in the ecosystem. And the methanogenesis process is also very important because the methane is also very important greenhouse gas that might emit by the marshes. Nevertheless, this study shows that the marsh ecosystem have the potential to increase their carbon uptake to compensate for the increasing atmospheric CO2. However, the ecosystem and its function as climate mitigations are under influence by many environmental and human factors. Therefore, better carbon management strategies are needed for us to better protect the ecosystem and its valuable functions. Thank you.